So 6.4, here we go. We, in this lesson, are just going to do this first one. We're going to interpret the chi-square distribution and use the chi-square distribution table. Our point estimate for constructing a confidence interval for a chi-square distribution is going to be the variance, right? Or the standard deviation, or the variance of the sample. Okay. All right, so in the chi-square distribution, we can construct a confidence interval for the variance and standard deviation. If we got a random variable and it has a normal distribution, then we can look at the distribution of chi-squared as being the size of the sample minus 1 times the variance of the sample divided by the standard deviation of the population. And that'll form a chi-square distribution. All right, so all chi-square values are greater than or equal to 0. Okay, so you will never have a negative value. That's what that says. The chi-square distribution is a family of curves, and the curve changes, of course, depending on the sample size, right? Which is what determines your degrees of freedom, right? Yeah, and we'll have a picture of it later, so we can talk about it a little bit more. And as with any probability distribution, the area underneath your curve is equal to 1. If the area underneath the curve is not equal to 1, it is not a probability distribution. So this is what it looks like. You guys have a picture of it on your chi-square table that I gave you. Just notice that, right, as your degrees of freedom increase, in other words, as your sample size increases, this becomes wider. It becomes more and more normal, right? If you look for your 30 degrees of freedom, it looks more and more like a normal curve. But normally, this thing is skewed to the right. So it's a right skewed distribution. And that's what this is, essentially. So we're going to be able to find some critical values for chi-square. We're going to actually be finding 2 critical values, depending on the level of confidence. We're going to have a right tail critical value and a left tail critical value. And I'll go ahead and write down the formulas for these, but they are actually right here. So 1 minus c divided by 2, that's how you're going to get that the left tail of your critical value, and then 1 minus c divided by 2 you're going to get your right tail. For the area. It should be plus.
So 1 plus c divided by 2 is the right?
It's what it turns out to be. So I'll put it in I'll put it on the other slide. Because you're having to subtract from 1 there. So that's why you wind up with a plus. So let's go ahead and put this thing to work. Let's go ahead and find some critical values for a 90% confidence interval. All right. So our area for our chi-squared sub r is going to be equal to, first requires that we find our degrees of freedom. So first thing we need are our degrees of freedom. So our degrees of freedom, where that's n minus 1, so 30 minus 1, which is 29. All right? And then I'm going to go 1 minus c divided by 2. And that's going to be 1 minus 0.9, right? That's our confidence level divided by 2, which turns out to be 0.05. Next thing we need to do is find the area. For our chi-square sub L, our left tail. And that is going to be 1 plus c divided by 2. And that's because you have to subtract the area from the so 1 plus 0.9 divided by 2 turns out to be 0.9. Alright, once we've found these, this is where we're going to use that chi-square table that I gave you. We're going to have to use this chi-square table. The same way we use the other tables to find critical values, we're going to look at our degrees of freedom, and we'll match it up, and then we'll find that critical value. So let's get our table out. And let's have a look at this thing, okay? So, up here, this top row, direction, this is where we're looking for the areas that we found, okay? So in this case, we found an area of 0.95, this one, and we found an area of 0.05, right? The degrees of freedom that we had was 29. Okay? 29 degrees of freedom. So we go to 29 degrees of freedom. Oh, I thought that was going to be cool. Didn't happen. So I thought we were going to get to point at it. So our 29 degrees of freedom, then, we're going to get a critical value of 17.78 and a critical value of 42.557. So we'll go through this. We'll go. So my critical value here is, that was for the point, I think this is, yeah, this one's for the, so 42.55. And then our critical value for the left tail is 17.70. 17.70. And that's how it's done. And you can also, sorry, the notation that you use for this turns out to be the actual chi-squared sub R. And this is our critical value for chi-squared sub L. Right, so the one on the top is the area that corresponds to the critical value, but these numbers that we found from our table are our actual critical value. All right, so that's it. So we'll spend the rest of the time working on this, and we'll probably get some time to work on it.